Hi, John is passing back the tests, so he'll get to you in a second with your exam. But I did put the grades already into WebAssign. Finally got them done yesterday evening, so I put those in and updated the grade book. So your average, whatever it says, it's going to be more than 1.47. That's pretty up to date, okay? Where we are right now in the class through two tests. So take a look at that and see where you are in terms of your grade. The good news is there's only one more midterm test, so you only have to sit through one more midterm test, and then there's the final exam as well, possibly, unless you're going to have collected enough currency to buy your way out of the final exam. Some people might be getting close to that, might be at that level. And now I haven't updated the currency for since right before the test. So if you went to some of the SI sessions for the test, I haven't added your dollars for attending those SI sessions, and I haven't updated it relative to the grade on the test. Remember, there's a slight penalty on the test if you or bonus if you score, above or below certain thresholds, right? So look in the syllabus, and you may start thinking about now about how you're going to use your currency. Some of y'all will be able to buy points on your midterm tests. So think about that. It's $3 a point, so those points might contribute to your midterm average on your tests. And then also, if you want to replace your low test score with the final exam score, so if you made substantially better on the second test than on the first test, or possibly on the first test rather than the second test, then you might be thinking about replacing one of those midterm test scores with your final exam score. And that takes a certain amount of currency too, right? So you can be sort of speculating now about what you can do to at the end of the class to improve your average. So certainly between now and the end of the class, you want to take advantage of your currency opportunities, right? Okay, so you can collect as many extra credit options as possible there by the end of the class. I moved apparently I really struggled with this one because we went over it very quickly prior to the exam. I moved the marginal analysis homework back a little bit. So this is, I don't know what day this is. What's April 10th? Huh? Sunday? Okay. So anyway, it's not due till, that's Sunday? Yeah, that's Sunday, right? So it's not due till Sunday. So there's only 8 problems on that. So you have a little bit extra time to finish that. But I'm going to show you that. We're going to do some problems on that today. If you were thinking about the test and not thinking about when I talked about this right before the test. So we'll review that a little bit. It's not really difficult. So when you see it done, it's not really hard. So that'll be easier to finish than maybe it seems. And then we're going to look at a few of the questions on the test, the ones that really stumped a lot of people, okay? And then hopefully we'll get into section 3.4 because I've already posted a bunch of additional homeworks, and I hopefully will be able to talk a little bit about 3.4 so you'll know how to start that one. So I may have to adjust these due dates, although I think you still got plenty of time to finish 3.4 even if we... well, I don't know. I may have to adjust that a little bit. So we'll see how far we get today anyway. Okay. So we've got some more homeworks posted. So John's passing out the test. Okay. I'm going to start talking about the test, though, so while John's passing it back. So in a minute, you'll see your test. But again, you can already see your grade there if you log on to WebAssign. The average on the test was exactly the same as the average on test number 1, exactly the same. Well, it was maybe 0.2 different. Okay, so it wasn't a bad average. It could have been better, right? So. And I think when you see, I've already posted the answers, so the answers were posted last week. But when we look at some of these questions, I know you'll find them not as difficult maybe as when you were sitting here taking the test. So make sure that you review your test, right, and look at where you missed points and why you missed points on particular questions. Of course, if you know you didn't study properly for the test, you didn't prepare properly for the test, if you know that's the case, then I can only exhort you to, to make sure that for the last midterm you prepare better, right? Okay, if that was an issue, okay. So if you know you didn't prepare well, then don't make that mistake on test number 3, and then on the final exam, okay. All right, so. There were a variety of small mistakes on most of the problems. This interpretation problem, which was really just a fill-in-the-blank problem, very much like the homework questions, interpretation homework questions, I had a few sloppy answers here that cost people points. I think this was worth 5 points. That cost people points. So try to be more careful about these interpretations because you really do have to be kind of exact in your language, okay, for the interpretation. So be careful about that. So this one gives us in this problem we have a revenue formula for Brenda's bike rental. So it says X here is the monthly demand. That's the number of bikes rented here at Brenda's. And that's in hundreds of bikes. The units of measures are really important. And then the revenue is measured in hundreds of dollars. So notice the very first expression there, that very first equation says R prime, right? R prime. So that's a rate of change. That's a marginal revenue. That's not the revenue, but that's the marginal revenue. R prime of 1 is equal to 8, and so we just want to interpret this value in the, in the context of the problem. Okay, so all you got to do is fill in the blanks here. So when the monthly demand is, okay, so see the input to both the revenue and the marginal revenue is going to be X, which is the monthly demand, right? So now you know the monthly demand is 1, but you don't want to put a 1 here, right? Because the demand is measured in hundreds of bikes. So what you should have filled into that blank is preferably you would have written 100 bikes. Some people just wrote 100, and I might have scribbled on there that it was 100 bikes, okay? All right? So it's that's the beginning there. The monthly revenue then from Brenda's bike rental, right? And again, this is a rate of change, right? Because this is a marginal revenue. So it increases because that's a positive marginal revenue, right? 8 is a positive number. So in your interpretation, you're going to say that the revenue increases, right? And then here's always the tricky part, right? The rate at which the revenue is increasing, okay? So this going to this value is going to relate always to the output from the marginal revenue function. So the output here is 8. That's going to be the same as the output from the revenue function, which is hundreds of dollars. Okay. So what you should have written in here is that the revenue is increasing by 800, and don't just say 800 though. You want to say it's $800. So be sure to put in the unit of measure, okay? And then per, and the per here is really the easy part because for these marginal type question or these rate of change type questions, the per is always easy because that's always 1 unit of input. 1 unit of input. So 1 unit of whatever your input is. Our input here is bikes, right? But 1 unit of that input would be not 1 bike, but 100 bikes, because the input is measured in hundreds of bikes, okay? So the completely correct thing to say there is the revenue is increasing by 800 per 100 bikes. But of course, you can immediately see that if it's 800 per 100 bikes, right, then you can simply divide there, and it's going to be $8 per, per individual bike. So you could have gotten away with saying $8 per bike. Technically, it's $800 per 100 bikes, okay? But don't say $800 per 1 bike, okay, right, or $8 per 100 bikes, okay? It's either $800 per 100 bikes or $8 per bike, okay? So that was the right way to interpret that. And so some people flubbed this one, and then there was a marginal cost on the next page that you interpret very similarly, okay? Very similarly. I'm not going to look at that one. But we will look at the interpretation of the marginal profit, which is the very last question, I think. And there I didn't give you a template. I just said, just give me the interpretation on your own, not just fill in the blanks. So we will look at that one, okay? Most people did the marginal revenue function correct, right? You just took the derivative of that revenue formula. So that's easy. That's 16 minus 8x. So almost everyone got that right, okay? Now, what's the profit function then, okay? Well, remember, profit is always, and we're going to see this again today because this is sort of the core of the marginal analysis homework. Profit is always revenue minus cost, okay? So to find the cost function, you just take your revenue function minus your cost function. Here's the mistake that most people were making, though. They had just written down the marginal revenue function. So instead of writing the revenue function minus the cost function, they wrote the marginal revenue function minus the cost function. You see what I'm saying? They filled in this formula here and then subtracted off the cost function. I know why you did that. That was just a careless mistake because you had just written down the marginal revenue function. But profit is the total revenue minus the cost. It's not the marginal revenue minus the cost, okay? So what you should have correctly filled in here is this formula minus the cost, see? So this was a mistake, right? Okay? You wanted to fill in the 16x minus 4x squared minus the cost. So the correct answer was 16 minus 4x squared, and then minus the cost function there, which is 4x plus 1, and then you just simplify that. So you end up with 16x minus 4x squared minus 4x minus 1, which I think comes out to be what? 12x minus 4x squared minus 1. So there's the right answer. Okay. So a lot of people knew that, I want to subtract revenue minus cost. Okay, that's great that you knew that. But then you just inadvertently filled in the marginal revenue as the revenue function, not the actual revenue function, okay, in here. Okay, here's the one now that, boy, all right, so this is really frustrating to me as an instructor, but maybe partly my fault, okay? You just wanted to interpret this equation, okay? And that is really an easy equation to interpret, okay? But people made it more difficult than they needed to, okay? So that's always a bugaboo when you're taking tests, is making questions more difficult than they actually are, okay? I'm really asking you a very simple question here, and some people made it more complicated in this one too, actually. Some people made it more complicated than they need to. So notice this says P of 0 equals minus 1. That is P, which is the profit. That is not the marginal profit. That is just the total profit, not the marginal profit, okay? So when you write down your interpretation here, you're not going to write down the words increase or decrease, okay? Increase or decrease refers to a rate, and that is the those sorts of words are when you're interpreting marginal profit or marginal revenue or marginal cost, okay? Marginal profit, marginal revenue, marginal costs are increasing, decreasing type interpretations. This is just plain old profit, okay? So you're not going to have the word increase, decrease in there. So a lot of people had the word decrease in their answer because they were looking at that negative output there, okay? But decrease should not be in your answer, all right? So what is the correct interpretation here of the total profit, okay? So total profit, what is that input 0 telling us? We're interested in calculating the total profit when what is the case? When nothing is sold, that's right, okay? Or in this case, when no bikes are rented, all right, okay? So a lot of people got that part right, okay? So it's you just start there, right? If no, or you could say 0 here, right? If no bikes are rented, then, and again, we're not going to have increase or decrease here, right? This is just a straightforward function notation interpretation, right? So what is that output telling us? What's the profit? What now? That's right. They lost $100, right? Or the profit is negative. Okay, right, okay. So if no bikes are rented, obviously you're not going to make any money, right? If no bikes are rented. In fact, you're going to lose money, right? Okay. So if no bikes are rented, then the loss is $100. You could say it that way. Or you could have said... you could have said the profit is negative 100. I would have accepted that also. Okay, all right. Of course, negative profit is a loss. So just a very straightforward interpretation in that case, all right? Not a rate of change. Remember, if it's going to be a rate of change interpretation, you're going to have the prime here, right? Okay, and no prime here. So this interpretation just refers to total profit. So you really got to look at the notation very carefully. Mathematical notation is very subtle sometimes, but it's very precise, okay? So you've got to interpret it precisely to indicate to me, right, that you're understanding the meaning of the notation. All right, okay? So then the loss is $100 or the profit is negative $100, okay? Or they lose $100. Lots of ways of saying that, okay? To get the same idea. Across, right? Okay, let's skip down to problem number 3. I'm only going to do the first part of this one, okay? The first part of this one. And just because this one was missed a lot. And so this is about cost of producing these wireless speakers, right? Okay? And you're given a cost function, right? You're given a cost function, and then you're asked a question about the cost. But you're not asked a question about the total cost. Cost functions give you total cost, right? This question is about the average cost per speaker. So I underlined that to try to draw your attention that I was interested here in average cost, not total cost. But for a lot of people, they weren't paying attention to that, okay? So that's a question of making sure that you read the question very carefully, right, okay? And I know sometimes you're in a hurry when you're on a test, right, and you take shortcuts. You just sort of glance at the problem and say, oh, yeah, I know what's being asked there. So, you start working on the problem. But make sure that you read the problem carefully, okay? so you know exactly what you're being asked for. All right, now to find the average cost, though, you are going to have to find the total cost. Okay, you can't find the average cost without finding the total cost. So you are going to use the total cost function, which is just given right there, right? Okay, and you're going to plug in an input of 1, okay, because we're being asked an average cost when 1 million speakers are produced here, right? In this formula, the input is being measured in millions, so you don't have to plug in the number 1 million into the formula. Good thing, right? Because then we'd have a hard arithmetic to do. You just have to plug in 1 into the formula and calculate the total cost, right? So that's easy to do. You're just going to have 1 squared plus 1 plus 2, and that comes out to be 4, right? So what that tells us is that when we're making 1 million of these speakers, the total cost is going to be $4 million, right? The total cost is going to be $4 million. That's the total cost, but that's not what we're asked for here. We're asked for the average cost per speaker, okay? So what was the average cost per speaker, right? And now that's easy to calculate, though, right? Because if you make 1 million speakers, right, then what was the cost for the 1 million speakers? What did we just say? $4 million, right? Okay, so the total cost there was $4 million. So you're just going to take your $4 million total cost and divide it by the 1 million speakers you produced, right? Okay, and that's going to give you your average cost per speaker. So dollars per speaker, okay? So the right answer there is $4 per speaker. So when we they're averaging $4 a piece, okay? When we manufacture 1 million, it's going to cost and none of that is mentioned in this particular problem. So through that one, first problem.
Here, so it wouldn't be wrong. It's just for my thing because I double-lined it, just for my remembrance.
Let's look at it later. Okay. All right. So let's go to the last page now. So a lot of people, y'all did really good on the differentiation rules for the most part. You know, there are some flubs, you know, of course, you know, so there are going to be mistakes here and there. But for the most part, y'all were pretty good with the differentiation rules, so I was happy with that, okay? And, oh, not quite to the last page, this one. Well, this one caused a lot of issues. This is another easy question, all right? Okay. But okay, so that messed people up. I'm running too many things at once here now, so that's why the screen is blinking on me. Okay. That's nice. We don't have to do any interpretation. It just 12x. Right? That's the formula. You can easily change of x squared minus 12. And so it says use the rate of change function to find the exact value for x where the tangent line to this curve has slope minus 1. Okay? I'm not exactly sure where that would be yet, right, on the curve. I can't really tell that from the graph. But we can see, right, that somewhere on this graph, the slopes of the tangent lines are negative. In fact, it's over here on the left-hand side, right? Because if you draw tangent lines over here on the left-hand side, here's just one as an example, right? So I don't know where I drew that tangent line exactly, but just as an example, that tangent line has negative slope, right? Because that tangent line is going downhill from right, okay? Plenty of x values where if you draw the tangent line, right, you're going to end up having a negative slope for the tangent line. You're going to have slope. That's where the curve is decreasing, right? But I want to find out exactly what slope of the tangent line turns out to be exactly -1, okay? Is what you use to find slopes of tangent lines, right? Okay? Use it to find rates of change. That's what the rate of change function is good for. But those rates of change are the same as slopes of tangent lines. So all you're looking for is where does this in so many words, okay? So all you have to do here is take that rate of change formula, right, which gives you slopes of tangent lines, and just set it equal to -1 and solve that equation. So tip marginal analysis homework and just it in is -1. Usually you want to find where the slope of the tangent and interest to us than okay. But I was just trying to mix it up a little bit. Slope of 0, okay? All right. So all of you now can solve this simple equation, right? All you have to do is add 12 to both sides. And so you get 2x is equal to 11, and then divide both sides by 2. So you end up with 11/2. So that's the answer. Now, if you wrote 11/2 down there, and I didn't see the work, because you have to do a little bit of work, okay, to get that answer. Not a lot, 2 or 3 steps maybe, but you have to do a little bit of work to get that answer. If I didn't see your work, then I'm not going to give you credit, okay? Not going to give you credit. So you can cry and moan and scream and, yeah, I don't know, get on the floor and beat your fist into the ground or whatever, but I'm not going to give. So it doesn't take a lot. last page there. So here's problem number 6. All right. So here we're given a profit function. Okay. Here we're given a profit function. So finally we get to profit. You're just given to it. You did, given the profit function. You didn't have to find the profit function. This is for wireless headphones. In rate of change. Is 3 million headphones. All right. So you just have to plug 3 there into the formula. Some people made arithmetic mistakes there. Feel really bad if you plugged it in right and made an arithmetic mistake. Okay. But the answer turns out to be 7. So so what that tells us, of course, is, right, when the demand is 3 million, right? Or in other words, when 3 million of these headphones are sold, then what's the case? I'm asking you all, what's the case there? That's right. The profit is 7 million, exactly. Okay. So no rate of change there, right? No rate of change. Just plain old, straightforward. When the demand is 3 million, the profit is 7 million. Actually, y'all did way better on this one than on the first page, the profit question. Okay? Is it just that the zero threw you off, or the negative profit threw you off? Okay? Profit can be negative. I wish it were always positive, but that's, if profit were always positive, we'd all be, flying our own private jets, right? Profit is not always positive, right? Sometimes people lose money, okay? So just keep that in mind, all right? Our marginal profit function, well, that's just the derivative of the profit, right? So almost everyone got that right. 7 minus 2x, right? So y'all are good at finding those rate of change formulas now. Very easy. This one's very easy. So 7 minus 2x. And then the last one is the interpretation. Okay? So finally there you can use increase and decrease now, right? What is p prime of 3? I think it turns out to be 1 because you're just going to plug 3 into this formula, right? So that's just going to give you 7 minus 2 times 3, which is 1. Dollars per 1 million. then again, make sure you go back and review your test, okay? I should say, not everyone makes careless mistakes, because we did have a 100 on the test, okay? So I know it is possible to make a 100, okay? Had a 100 on the test. All right. Any questions? So if you have specific issues on your test, then you can ask me later, and we'll look at that, okay? Okay. Let me close that. I want to go back here, and let's look at the marginal analysis homework now. So I can demystify this a little bit, because it's really not as bad as it looks. All right. I'm not going to do. I can't do every problem on here today, but let's look at just a few questions. I don't know if these are the ones that were really throwing you, but I picked some here to go over. Okay. So. You can help me. All right, so I'm looking at the version actually that where the answer is showing here. All right, so actually let's not look at that one. That may be dangerous. Let me go ahead and open it in the student view. Okay, let's look at problem number 4 first, okay? Number 5 with, well, maybe in 4 too, doing some calculations. All right, so this says so this is just a straightforward cost function, right? Okay, so you're given a cost, and so there's the cost, and given the revenue formula, okay, so you're given the revenue formula also, and then it just says find the production level. They don't tell you what this product is that's being produced here. The profit. Okay. All right. Can y'all write those formulas down for me? Because I'm going to switch here to back. At a particular right? Minus the cost, the revenue items minus the cost for producing those items, right? Okay, and then we just have to fill in the formula for the revenue and the cost. All right, so let's simplify that just a little bit by going ahead and distributing that minus sign through those parentheses, right? And then we can add some like terms. So all this is just simplifying the profit formula. And we really don't have to do that, but I think that would make things easier in the long run. So we're going to have minus 2250 and then plus, right, was that minus 3.8Q? It was plus? Yeah, okay. I was thinking that's a little bit strange. So this was plus, which means this is going to be minus now when we distribute the minus sign. Okay. And then the minus 0.004 Q squared. Okay. And now we do have some like terms that we can add together here. You've got a 12.2 minus a Q minus a 3.8 Q, right? So that is something like 8.4 Q. Y'all agree with that? 12.2 minus 3.8, is that 8.4 Q? Yeah, okay. And then we've got these Q squareds, right? Okay, so here I have a minus 0.002 Q squared and then a minus 0.004 Q squared. So that's minus 0.006 Q squared. Right? And then the minus 2250, right? Okay. So there is our a total profit. Homework, okay? But I'm just trying to motivate here what we're getting ready to do. Let's look at a graph of our profit function, okay? So let's look at a graph of our profit function. So again, I want to make sure let's make a graph of this. And that's almost the right formula. So I already typed this one in, but I had a slightly different version of the formula here. So let me change this to the correct version of the formula. So that coefficient on the Q is supposed to be what, 8.4? So it was 8.4 Q and then minus 0.006 Q squared, right? And then minus, not 2150, but what was it there? 2250? Okay. All right. And, all right, so there's the correct graph and of the profit. So you can see what's happening to the profit here, right? Okay. As our production level goes up, here's the production level, right? So as our production level goes up, our profit is indeed increasing, right? So that's good. And right there, notice right there is a break-even point, right? Because that's where we're to finally have there. So that looks like the graph, right? That a production close to 700, rather large. So I'm not quite sure if this peak point is at 700. When you get past a production level of 700, a thousand, maybe 1,030. So it's right here in the middle of the curve. That's where the profit is going to be highest. But we've got to figure out exactly what's that production level. Exactly what is that production level that gives us the maximum profit, okay? But we don't want to guess at it from looking at the graph. We do not want to guess at it, okay? Right? If you just guess it, we don't. Where the tangent line is flat and so that's all we're trying to do here is find out where the rate of change is 0. That must be where we have that maximum profit. Well, we don't. Right? What is the rate of change for? See, right? It's a production level, right? The quantity we want to produce is 700 in order to maximize the profit. And if you want to find out what the maximum profit is, then you would take the 700 and plug it into your profit formula, not your marginal profit formula, but take the 700 and plug it back into the original profit formula, and that will tell you what your maximum profit is for this particular item, right? So I'm not going to do that calculation because we weren't asked for that in the homework, but that's how you actually determine the maximum profit. Just take the 700 and plug it not into the marginal profit, but back into the original profit formula, which is right there, and you can calculate what the maximum profit actually is, okay, for this particular item. All right, let's try another one now, if I can get back to the homework here. Let's get down to number 6, okay? Because here, this is exactly the same problem, but you're going to have to add one extra step here. So, you can just make up some. Where's the cost? And equation relates price to quantity sold, okay? Price to quantity sold. That is what a demand equation does for you, all right? So it relates the price goes up, right? Typically for most items, or when price goes up, demand goes down, okay? And so here, for this particular item, is the actual formula that relates the price and the demand. So P here is price, of course, just like you would expect. That in one lecture, but we went through it very quickly, so that's probably why you forgot it already, right? So let's look at that again. So did y'all write these down for me? Because I gotta have to write them down in my notes now. Okay, so what was the cost formula? So that we were given. We didn't have to figure that out. So that was what? 600 and what? 60. Plus 2Q, and then minus something there. Oh, plus again. Plus what? 0.01 Q squared. All right. So did I write that right? Okay. All right. So there's our cost, right? And what was the formula that related? Oh, it wasn't X. They're using always. I always use X for demand, but the homework switched that on me. Okay, so they're using Q. All right. So, and now what was the equation that related price and demand? So it was what? 11? 300? Oh, okay. All right. So 11 minus Q over 300. Okay. All right. So just like before, just like in that previous example, if you want to know the profit, you've got to know the revenue, right? And you subtract off the cost. But what we appear to be missing here is what is the revenue formula, okay? What is the revenue formula? So before I can, continue to analyze the profit, I've got to somehow figure out what that revenue formula is, okay? All right, so let's stop here for a moment and figure out what our revenue formula actually is. Okay, look, the basic way you determine revenue, okay, at its most basic level, okay, the way you determine revenue is you take the amount of an item you sell, that's the demand, right? Okay, and so how are we representing demand in all these formulas? No, demand, the amount we can sell, Q, right, yeah, think of quantity of demand, all right? Q for quantity, okay? So to calculate revenue, you take the quantity that you sell times the price for each item, right? Okay? Correct? Isn't that pretty straightforward, right? Okay? You take the quantity that you sell and you multiply it times the price that you sold each item, and that's the revenue that you're going to generate, okay? So there's the have a formula with both Q and P in it. I Q in it, right? Okay, so somehow I've got to figure out how to eliminate or replace that P. Equation helps me see, because I know, right, the relation between price and demand, right? The P is equal to, the price is equal to this expression. So I can take 11 minus Q divided by 300, and see I can substitute that in this equation for P. Because that's the relationship between the demand and the price. So where I have the P here, I can plug in 11 minus Q times 300. And so when we do that, let's see, what do we get? We get Q times 11 minus Q times, Q divided by 300. Okay. And let me write that Q squared over 300. Let me write that with uh, 300. Let's write that Q squared over 300 with decimals. So take 1 divided by 300 on your calculator. What is 1 divided by 300 on the calculator? What now? Point what? 0.0 0 and then a bunch of 3s after that. Okay. All right, so let's try a couple of 3s. I'm just going to write 1 3 there. And Q squared. All right. So there is my revenue formula. Okay. And now everything is just like in the previous example. All right. So my, I'm sorry, this is supposed to be a Q right there, right? So I have 11Q minus 0.003 Q squared, right? Minus, and then this big cost formula, which is 660 plus 2Q plus 0.01 Q squared. So I have 11Q minus the 0.003 Q squared minus the 660 minus the 2Q and then minus the 0.01 q squared. And now just add your like terms together. And so it looks like we end up with 9q and then minus 0.013 q squared, and then minus 660. There it is. There's the profit formula. Okay. And now, how do we find out where the profit was maximized? You're looking for where the rate of change is what? That's right. So you're looking for where the marginal profit is 0. Okay, where the marginal profit is 0. So take your calculate your marginal profit and set that equal to 0. Remember, marginal profit means rate of change of profit, right? So we want to find where the rate of change of the profit is 0, because that's where our profit function is going to have a horizontal tangent line. All right, so what is our marginal profit there? Looks like 9 minus 0.26 q. And we set that equal to what? Yeah, just set that equal to 0. Okay, and now just solve that equation. So I hope we wrote down enough decimal places to back here to solve that equation correctly, but in any event, we have 9 equals 0.026 q. Okay, and so it looks like that quantity that we're looking for to maximize the profit would be 9 divided by 0.026. So what is 9 divided by 0.026? 346.154, which is close to 346, right? Okay, so it looks like the profit is maximized right there at 346. Okay, that's our answer. So see, not all that bad. And so I think all the problems in the marginal profit homework there are very similar to some a little bit easier, some a little bit harder. The rate of change of the rate of change of this, you're going to bring the 2 down right. Find this coefficient. Did that off to 0.003, and it was really 0.003333333. Okay, it's a little bit hard to know how many decimal places we need. 346 is close enough. All right. If you need, if that turns out to not, in order to get a more accurate result there. Okay. All right. Okay, so we've just got enough time here to, I'm going to introduce you now just introduce you, so we won't get very far into this because we've only got a few minutes here. So I want to show you now another rule for differentiation, okay? Because although we know how to find the derivatives of lots of different formulas now, believe it or not, we don't know how to find the derivative of every type of formula that we might want to find the derivative of. So I want to show you here a very powerful rule called the chain rule, and give you just maybe one example, at least today, of the chain rule and how that works. So this is just another rule for differentiation. This is another tool that you can use to help you find the rate of change of a function really easily, without having to go through all that ugly limit process, right? Nobody liked doing that on the test. I could see that. That was problem number 3B, okay? So I know you want to avoid that as much as possible, and that's what the rules for differentiation are, okay? All right, let me explain the chain rule to you, all right? But when you see it in formal, the rule written out formally, it doesn't have much meaning until you start seeing some examples, okay? So suppose you have a as the composition of two functions, okay? So suppose your function can be written as the composition of two simpler functions. So in this example, I start with a function called f, or in this way I wrote the rule. Start with a function called f, and suppose you can write f as the composition of two simpler functions, g and h, okay? Suppose that's possible for some reason. Then what the chain rule says is that you can find the derivative of that function f by taking the derivative of the function g, okay, in this composition here. Take the derivative of the function g and multiply it by the derivative of this function h, okay? So the chain rule of differentiation, a composition and turning it into a product. This turns out to be a really powerful method to help you find rates of change formulas. Suppose their formula for f is plus 6x squared. What the chain rule says is, let's see if we can take that function f. Let's see if we can take that function f and write it as the composition of two simpler functions, g and h. So I've got to see if I can write down these two functions, g and h. All right, in this example, I'm just going to show you what the two functions are. So I'm going to take that function g that I need in this composition to be x squared, and then I'm going to take the function h to be 5 plus 6x. Now, first, I've got to get you to agree with me that if you take these two functions, g and h, and you compose them in this way, you will get the function f, okay? So first we've got to check that, all right? So now what does it mean when I write down g of h of x? That means I'm going to take my formula for h of x, right? And I'm going to plug that in to the formula for g. Okay? So let's see. What happens when I do that? So what's the formula for h of x? It's 5 plus 6x, right? And now I'm going to plug that in to my formula for g. Okay? So what does the function g do with its input? All it does is take it and do what? Square it. So if you plug h of x, 5 plus 6x, into this formula, all you're going to do is take the 5 plus 6x and square it. So I take 5 plus 6x and I square it. See? So if you take h of x, 5 plus 6x, plug that in for x in this formula, all you do is take the 5 plus 6x and square it. Does that give me the original function that I was starting with here, f? Is this the same as this? Sure, right. Okay, those are the same. So I did manage to write down these two functions, g and h, okay, so that when I compose them, I get this original function f. All right? When you've got that set up, okay, when you have that set up, then you can apply what's, again, called the chain rule, okay? And what the chain rule does, again, is allow you to find a derivative, all right? All right, so let me write down again what the chain rule says. What the chain rule says is I'm going to take the derivative of my multiply that by the derivative of the function h. What is the derivative of the function g here? So what is the derivative of x squared? Y'all are really good at... No, x squared. What is that now? Yeah, that's just 2x, right? And what's the derivative of the function h? What now? 6, right. That's just 6. So when you're looking at this chain rule, here's the first easy mistake to make. You're thinking that says the derivative of g of h. It's telling you to find the rate of change of the function f, just take the derivative of g, there we've got it, right, and multiply it by the derivative of h. So you're going to think there, okay, that's easy. I can just take the 2x and multiply it by the 6, because that's the derivative of g, right, and that's the derivative of h. So you're thinking, oh, easy rate of change there, it's just 12x. But that's not quite what the chain rule says. This is what I have to point out to you. It says take the derivative of g and plug h into it. Okay? Plug h into it. Then multiply by the derivative of h. So you're not going to write down just 2x plus 6. You're going to what in for x? H, which is 5 plus the 6x. And then multiply it by the derivative of h. So this is not, it's almost the right formula, but this is not quite the right formula. What we really should have written down was 2 times 5 plus 6x, and then multiply by the 6. Okay? So it's and then multiply it by the derivative of h. That's the correct rate of change formula. Let me show you what that really looks like. So, okay, that's the chain rule, but let me show you what we really did here. Okay. The derivative of a power You bring it down, right? Okay, and then do what? You subtract 1. But we just had to throw in one little extra thing. What did we have to multiply in here? The derivative of the 5 plus the 6x. We had to multiply that in. Okay, you see that? So we took the 2, 5 plus the 6x, subtracted 1 from the exponent, right? But then we also had to multiply is really doing, okay? It's really using a rule that we've already used with just one extra step to it, okay? That's necessary. Okay, we're out of time, way out of time. We'll look at more examples of the chain rule next time, okay?